Hello students, let's practice some questions on heights and distances today, right? So let's begin with question number 1. A person standing on the bank of a river observes that the angle subtended by a tree on the opposite bank is 60 degree. When he retires 40 meters from the bank, he finds the angle to be 30 degree. Then the breadth of the river is. So let us consider position of the person somewhere here, right? So let his position be at A, and he is standing on the bank of a river, observes that the angle subtended by a tree on the opposite bank. So let B be the position of the tree on the opposite bank. So let us consider a tree, and he observes that the angle subtended by a tree on the opposite bank is 60 degree. That means, so if you consider BC as the tree on the opposite bank, right? CAB, the angle subtended by the tree is 60 degree on the opposite bank. When he retires 40 meters from the bank, his position was at A. When he retires, when he comes back 40 meters from the bank, 40 meters from the bank, he finds the angle to be 30 degrees. So that means angle subtended. So let it be D. Angle subtended at D, right? Angle subtended at D by the tree is 30 degree here. So we'll consider CDB or CDA as 30 degree, right? So then the breadth of the river is, breadth of the river means, so we need to find the distance AB, right? So A and B are two banks of the river. So AB distance means breadth of the river. Let it be X, right? Breadth of the river be X. So for that, let us consider, so tan function, right? Here tan 60, tan function is opposite by adjacent side, and tan 30 also opposite by adjacent side, right? So you can easily find the breadth of the river. So let H be the height of the tree, right? H be the height of the tree. So here we'll consider H as height of the tree, height of the tree. Now we'll consider tan 60, right? Here we are going to find the value of X, which is breadth. Tan 60 is opposite by adjacent side. By the formula, it is opposite by adjacent. So opposite is H, height of the tree, and adjacent side is AB, which is X, right? So whereas tan 60 is root 3. Therefore, so height of the tree is root 3 into X. Consider this as equation 1. Now consider tan 30 degree. Tan 30 is again opposite by adjacent side. So tan 30 opposite side is height, right? Height of the tree. Adjacent side is dB, right? Which is 40 meter plus X. dB is 40 plus X, right? Therefore, height is equal to, what is the value of tan 30? 1 by root 3, right? 1 by root 3 into 40 plus X. So we can equate equation 1 and 2, right? Therefore, root 3x is equal to 40 plus x by root 3. So by cross multiplication, root 3 into root 3 becomes 3 into x is equal to 40 plus x. So therefore 2x is equal to 40. Value of x is equal to 20 meters. That means breadth of the river is 20 meters. Right? Therefore option C is the right answer. Breadth of the river is 20 meters. Question number 2. A paraglider, when flying at a height of 1000 meters above the ground, passes vertically above another paraglider at an instant. From the same point on the ground level, two paragliders form two angles of elevation 60 degree and 30 degree respectively. Find the height of the lower paraglider from the ground level. Here, student, there is a small correction in the question. So instead of taking find the height of the lower paraglider from the ground level, we have to consider find the vertical distance between two paragliders. Vertical distance between two paragliders. Since the options are given accordingly, that means according to the vertical distance, right? So we have to take vertical distance between two paragliders. Two paragliders, right? So let us consider a paraglider when flying at a height of 1000 meters above the ground level, right? So let us consider paraglider A, right? who is above the ground level, right? And who is flying at a height of 1000 meter, right? And who passes vertically above another paraglider at an instant. So we'll consider another paraglider B, right? From the same point on the ground level, two paragliders form two angles of elevation. So on the ground level, so we'll consider a point P, right? So from the same point on the ground level, so two angles of elevation are 60° and 30° respectively, right? So 60° at P by paraglider A and 30° at again the same point P by paraglider B, right? These are the two angles of elevations. So 60° and 30°. So here we need to find vertical distance between two paragliders. So the distance AB we need to find, right? So let it be H or X, any unknown value, right? So distance between A and B, right? So here, so we'll consider this point as Q, right? So since we are taking the opposite side of the angle, so it may be 60° angle, angle of elevation, or 30° angle. So we are considering opposite side and the angles. So only the trigonometric function which relates opposite side and the angle, and we are considering distance between P and Q as an unknown value, which is D. So which relates opposite side and the adjacent side is tan function, right? So again, as in the previous example, so we are using tan function here, right? So we'll consider tan 60. Tan 60, the angle made at P, the whole angle is 60°. So tan function says opposite side by adjacent side. Here opposite side of 60° angle is AB and its adjacent side is PQ, right? So AB, the whole distance is, right, the whole height is 1000 meter by PQ is D, since tan 60 is root of 3. Therefore, we will consider D is equal to 1000 by root 3, right? Consider this as equation 1. Now consider tan of 30°. Tan 30° is equal to, again, opposite side by adjacent side. So opposite side of 30° angle is BQ, its adjacent side is PQ. Since tan 30 is 1 by root 3, so here BQ is, this distance BQ is 1000 minus H, right? The whole height 1000 meter minus, so vertical distance between two paragliders, so which is H. So we'll write BQ as 1000 minus H by PQ, which is D. Again, we'll consider D is equal to 1000 minus H divided by, so it is not divided by, into root 3, right? 1000 minus H into root 3. Consider this as equation 1. So equation 1 is nothing but value of D. So equation 2 is also D. Therefore, we can equate 1 and 2. So therefore, equation 1 is equal to equation 2. So equate RHS, right? So right hand sides, 1000 by root 3 is equal to 1000 minus H into root 3, right? Simplify it to get the value of H, right? So here, so 1000 minus H is equal to 1000 by root 3 into root 3, which is 3, right? So 1000, we'll get 1000 by 3. We need value of H here. Therefore, H is equal to 1000 minus 1000 by 3. So which is another 3000 minus 1000, which is 2000 by 3 is value of H. So simplify it. 3 into 6, again 3 into 6, 3 into 6. So it continues 0.666, which is nearly equal to 666.67 meters is value of H. So what is H? Vertical distance between two paragliders, right? So which is nothing but 666.67 meters approximately, right? Therefore, look at the options. Option A is the right answer. right? Here students, so here we need to find vertical distance between two paragliders. For that we have to consider two angles of elevation, right? So made at the same point on the ground by two paragliders, right? A and B. So considering the angles and the opposite side and adjacent side, so here adjacent side let it be D, which is constant, right? So adjacent side is nothing but distance between a point on the plane and so the point which is Q, right? So it is constant. So by considering opposite side and adjacent side, we can take the tan function. So tan 60 and tan 30. So using these two, so we'll get the value of D, distance between P and Q. You can equate equation 1 and 2 here, right? So to get the value of H, which is nothing but vertical distance between two paragliders. So therefore, option A is the right answer. Question number 3. The angles of depression of two ships from the top of a lighthouse are 45 degree and 30 degree towards east. If the ships are 200 meters apart, find the height of the lighthouse. So students, let us consider a lighthouse. Let it be AB, right? Here we are going to find height of the lighthouse. Let it be H meters, right? And angles of depression of two ships towards east. So let us consider two ships, S1 and S2. S1 and S2 be the two ships, and the angles of depression are given. So here S2 makes an angle 45 degree, right? Angle of depression 45 degree towards east. So this means towards east, right? And S1 makes an angle of depression 30 degree. 30 degree, right? So if the two ships are 200 meters apart, here S1 and S2 distance is 200 meters. Find the height of the lighthouse. We are going to find height, H, right? So here the angles of depression are given and the opposite side is H, height of the lighthouse, right? And let us assume X be the distance of the second ship from B, right? So using opposite side and adjacent side, so we are going to go for tan function, right? Therefore, let us take tan function. So tan 30 degree is equal to, formula says opposite by adjacent side. Opposite side is AB. For 30 degree, opposite side is S1B. Since tan 30 is 1 by root 3, so which is equal to AB is height of the lighthouse H divided by S1B, right? So adjacent side is 200 meters plus X, right? Therefore, so height of the lighthouse H is equal to, so 200 plus X divided by root 3. So consider this as equation 1, right? Now consider tan 45. Again, the formula says opposite by adjacent side. So opposite side to 45 degree angle is height of the lighthouse, and adjacent side is S2B, which is X. Since tan 45 is equal to 1, so is equal to H by X. This means H is equal to X, right? So height of the lighthouse is equal to X. So this distance S2B. So substitute the value of X in equation 1, right? Because we are going to find height of the lighthouse. So equation 1 becomes H is equal to 200 plus X is nothing but H divided by root 3. So root 3H minus H is equal to 200, right? Therefore, so we'll take out H into root 3 minus 1 is equal to 200. So H is equal to 200 by root 3 minus 1, right? Since root 3 is 1.73 something, or 74 something. Otherwise, you can multiply multiply and divide by root 3 plus 1. Multiply both numerator and denominator by root 3 plus 1, right? So better to convert the denominator into a whole number, right? So 200 into root 3 plus 1 by, so the denominator is in the form of a plus b into a minus b, so which is a square minus b square. right? So 200 by 2 is 100 into root 3 plus 1. What's the value of root 3? So root 3 value by division method you can find out the value of root 3. Otherwise, directly I am taking the value 100 to root 3 is 1.732 plus 1, right? So 100 into 1.732 is 173.2 plus 100. So round off to the nearest whole number. So you will get 273 as height of the lighthouse, right? So height is 273 meters. When rounded off to the whole number, nearest whole number, you will get 273 meter as height of the lighthouse. Option D is the right answer. Question number 4. As observed from the top of a 135-meter tall lighthouse, the angles of depression of two ships approaching it are 45 degree and 60 degree. If one ship is directly behind the other, find the distance between two ships, right? So let us consider a lighthouse, right? So lighthouse is 135-meter tall, right? So we'll consider a lighthouse AB and its height is 135 meter, right? So angles of depression are given, right? Of two ships approaching it are. So let us consider S1 and S2. Two ships approaching the lighthouse and the angles of depression, right, are 45 degree and 60 degree. So here angle of depression made by, yes, the lighthouse by ship 1 is less than, right, ship 2. So 45 degree, this is angle made at S2 is 60 degree, right? So here we need to find the distance between two ships. So distance between S1 and S2, right? So let us consider X meter as distance between two ships and Y meter be the distance between the second ship and the lighthouse, right? So which is B, right? So we'll consider these two distances as X and Y. So we need to find the value of X here, right? So here, so with respect to angle 45 degree, we have its opposite side, which is height of the lighthouse, which is AB. Since angle made at B is 90 degree, right? And we have the adjacent sides X and Y with respect to these two angles. So we can go for tan functions because tan is opposite by adjacent side, right? So let us consider tan 45 degree is equal to, formula says opposite side by adjacent side, right? Here opposite side is AB, which is height of the lighthouse. And with respect to angle 45 degree, its adjacent side is S1B. S1B. Here AB is height of the lighthouse 135 meter and S1B, the total distance is X plus Y. And tan 45 is 1. Therefore, we can say X plus Y is equal to 135 degree, right? So next, let us consider tan 60 degree. Tan 60 degree is equal to, again by the formula, it is opposite by adjacent side. Opposite side is AB. With respect to angle 60 degree, its adjacent side is S2B. AB is 135 and S2B is Y. And tan 60 is root 3, right? Therefore, we can write root 3 is equal to 135 by Y, or Y is equal to 135 by root 3. Substitute the value of Y in this equation. If you consider this as equation 1, right, where X plus Y is equal to 135. Here we need the value of X. That means the distance between two ships, right? Therefore, so equation 1 becomes X plus Y is 135 by root 3, right, is equal to 135. Therefore, value of X is 135 minus 135 by root 3, right? So, which is equal to, take out 135 common, 135 into, right? So, 1 minus 1 by root 3 or 135 into root 3 minus 1 by root 3, right? Where x is distance between two ships. 135 into root 3 minus 1 by root 3 meter, right? Is the value of x. Look at the options. Option A is the right answer, right? Here, students, in this question, first we have to consider the lighthouse and its height, angle of depressions, right? Of two ships approaching the lighthouse. So angle of depression is 45-degree, right? So with respect to ship 1 and with respect to ship 2, it is 60-degree, right? Because the ship which is nearer to the lighthouse makes larger angle, right? Larger angle of depression. So therefore, S2 is nearer to lighthouse, therefore it makes a 60-degree angle, right? Whereas the other ship makes a 45-degree angle, right? So in order to find the distance between these two ships, we need to go for tan function because we have opposite side and adjacent sides under consideration here, right? So after solving for tan 45 and tan 60, we can easily relate x and y. And finally, we'll get the value of x as this value, right? 135 into root 3 minus 1 by root 3 meters is the distance between two ships. Hence, option A is the right answer. Question number 5. A cliff measures 80 meters from the foot of it on level ground. The angle of elevation of the top of the cliff is 30-degree. Find the height of the cliff. Here, students, a cliff is nothing but it's a mass of rock that rises very high and it is almost vertical. So let us consider a cliff, right? So mass of rock that rises very high, right? Cliff measures 80 meter from the foot of it on level ground. On level ground, it measures 80 meter, right? So that means, so if you consider A as foot of the cliff on level ground, right? And its height be h, height of the cliff from the ground be h, right? And this distance A to the cliff, that means let it be B, right? So let this point be B. A to B distance is 80 meter. That means, so length of the cliff is 80 meter. Cliff measures 80 meter from the foot of it. Means AB distance is 80 meter. And angle of elevation of the top of the cliff is given. So that means angle made at A is called angle of elevation of the cliff, right? So angle of elevation is 30-degree. Find the height of the cliff. We need to find height of the cliff. Let this point be D. We need to find BD, right? Which is height of the cliff. For that, here with respect to angle 30-degree, BD becomes opposite side, right? And we have the adjacent side of the angle. Therefore, the tan function relates opposite and adjacent side, right? Therefore, to find height of the cliff, we use a tan function. So, tan of 30 is equal to opposite side by adjacent side, right? Opposite side is BD and the adjacent side is AB. So, since tan 30 is 1 by root 3, so 1 by root 3 is equal to BD is height of the cliff divided by adjacent side, right, is 80 meter. Therefore, H is equal to 80 by root 3, right? Height of the cliff is 80 by root 3 meters. Look at the options. Here 80 root 3 by 3, right? So, the option A says 80 into root 3 by 3. So here H is equal to 80 by root 3 we have got. So multiply and divide by root 3. There will not be any change in the value of the equation, right? Right? So therefore, so it becomes 80 into root 3 and the denominator becomes a root 3 into root 3 which is 3 meters, right? Which is nothing but option A. So height of the cliff is 80 root 3 by 3 meters. Option A is the right answer. Question 6. A vertical tower stands on a horizontal plane and is surmounted by a flag staff of height 6 meter. At a point on the plane, the angle of elevation of the bottom of the flag staff is 60-degree and that of the top of the flag staff is 45 degrees. So this should be reversed here. So angle of elevation of the top of the flag staff is 60-degree. So bottom and top should be interchanged here, and that of bottom of the flagstaff. So is 45 degree. Since the angle of elevation of the top of the flagstaff is greater than bottom of the flagstaff, right? Therefore, so this should be reversed, right? So find the height of the tower. So let us consider one by one here. So vertical tower stands on a horizontal plane. So let us consider a vertical tower. So let it be AB, right? So stands on a horizontal plane and is surmounted by a flagstaff of height 6 meters. So a flagstaff is kept over the vertical tower, right? So height of the flagstaff is 6 meter. So let AC be the flagstaff, right? At a point on the plane, the angle of elevation of the top of the flagstaff is 60 degrees. So let us consider a point on the plane. So let it be P, right? Angle of elevation of the top of the flagstaff. Here, top of the flagstaff is C, right? If it is flagstaff, top of the flagstaff is at C, angle made at P, which is nothing but angle of elevation of the top of the flagstaff is 60 degree. This whole angle with the horizontal plane is 60 degree, and angle of elevation of the bottom of the flagstaff. Here A is bottom of the flagstaff, right? So angle of elevation of the bottom of the flagstaff with the horizontal plane is 45 degree, right? So we need to find height of the tower. Here two angles in a right angle triangle are given, right? And we need to find opposite side. Here height of the tower is nothing but AB. Let H be the height of the tower. So we are going to find opposite side of the angle, right? So by assuming the distance between P and B, a point on the plane and the tower, so let it be D. By assuming the distance between P and B as D, we can relate opposite side and adjacent side of an angle, right? For that we use tan function, right? As in the previous examples, here also we are using tan functions, right? So here h is height of the tower, right? So let h be the height of the tower, height of the tower, right? So let us consider tan 60 for plus, right? Tan 60 is equal to this whole angle made at P is equal to, so formula says opposite side by adjacent side. All right. Opposite side is BC with respect to angle 60 degree. Its opposite side is BC and the adjacent side is PB. Since tan 60 is root of 3, so BC is nothing but 6 meter plus H, right? So we'll write it as 6 plus H. By adjacent side is the distance between P and B, which is D, right? Let us consider this as equation 1. Right? So now consider tan 45 degree. Opposite side with respect to angle 45 degree is AB. AB is the opposite side, right? And the adjacent side is PB. So H by D is tan 45. Since tan 45 is 1, so 1 is equal to H by D. So therefore, H is equal to D, right? So here we need the value of H, not D, right? So substitute the value of D as H in equation 1. Therefore, equation 1 becomes root 3 is equal to 6 plus H divided by D is nothing but H, right? Therefore, root 3 into H minus H is equal to 6, or H into root 3 minus 1 is equal to 6, or height of the tower is 6 divided by root 3 minus 1 meters, right? 6 divided by root 3 minus 1 meters. So look at the options. 6 divided by root 3 minus 1 meter. So here option A and B are same, right? Right? So you'll consider option A as the answer. 6 divided by root 3 minus 1 meter. Question number 7. An aeroplane, when flying at a height of 2000 meters above the ground, passes vertically above another plane at an instant when the angle of elevation of two aeroplanes from the same point on the ground are 45 degree and 30 degree respectively. How many meters the lower aeroplane is one than the other? So, as in the previous question, in question number 2, here also we are finding the distance between two aeroplanes. There we were finding the distance between two paragliders. Here we are finding distance between two aeroplanes, right? So we'll consider an aeroplane. So A1, when flying at a height of 2000 meters above the ground. So distance from the ground. So let the point be P. So PA1 distance is 2000 meter. The whole distance is 2000 meters above the ground. So which passes vertically above another plane at an instant when the angle of elevation made, right? So we'll consider another aeroplane A2, right? So this first aeroplane passes vertically at an instant, right? So, of two planes from the same point on the ground. So angles of elevation are given, right? So let us consider a point on the ground Q, right? So at which two angles of elevations are made by two planes. Here angle made or angle of elevation made by aeroplane 1 is greater than the second angle, right? So which is 45 degree, and angle of elevation made at point Q by second aeroplane is only 30 degree. So small angle, right? Here, how many meters the lower aeroplane is one than the other? That means we need to find the distance between A1 and A2, right? So let it be H, right? H. So here the whole distance A1P is 2000 meter. So aeroplane A1 is flying 2000 meter above the ground, right? Therefore, A1P is 2000 meter. So which is the opposite side to angle 45 degree. Here also we are using tan function, right? So tan of 45 degree is, the formula says opposite side by adjacent side. So opposite side of angle 45 degrees A1P. Its adjacent side is QP. QP is a point on the ground, distance between point on the ground and the vertical point, which is P, QP, right? So let it be D. For our convenience, we are taking it as D, right? So tan 45 is 1 is equal to AP. The whole distance is 2000 meter, which is already given, and QP is D. Therefore, the value of D is 2000 meters, right? Consider this as 1. Now consider tan of 30 degree, right? So opposite side by adjacent side, its opposite side is A2P. By adjacent side is QP. What is A2P? So this distance is the whole distance 2000 minus H, right? So we'll take it as 2000 minus H by QP is constant, which is D. Since tan 30 is 1 by root 3, so which is equal to 2000 minus H by D. So we'll consider D. Value of D is root 3 into 2000 minus H. Consider this as equation 2. So we can equate 1 and 2, right? Both are same, right? So we'll equate right hand sides of equation 1 and 2. So 2000 is equal to root 3 into 2000 minus H. We are going to find the value of H because the question is how many meters the lower aeroplane one than the other, right? Therefore, we are going to find H value. So for that, so 2000 by root 3 is equal to 2000 minus H. So take this H to the LHS part. So H is equal to 2000 minus 2000 by root 3. Simplify it. So we'll take out 2000 as common term. So you'll get 1 minus 1 by root 3 or 2000 into, so by taking root 3 as LCM, so you will get root 3 minus 1 in the numerator. Therefore, so the distance between two aeroplanes is 2000 into root 3 minus 1 by root 3. So look at the options. Option A is the right answer. Question number 8. The angles of elevation of top and bottom of a flag kept on a flag post from 20-meter distance are 60° and 45° respectively. What is the height of the flag? So here students will consider a flag post first. So let AB be the flag post. Here flag post is kept at certain distance which is 20-meter from some point. So let the point be P, right? So from point P, flag post is kept at 20-meter distance, right? And a flag is kept on the flag post. Let AC be the flag. And angles of elevation of top and bottom of a flag are given. So angle of elevation of top of the flag, right? Here C is top of the flag. Angle of elevation, right, of top of the flag is how much? 60°. 60°. And angle of elevation of bottom of the flag. So here A is bottom of the flag, right? Angle of elevation is 45°. So A is bottom of the flag. Here we need to find height of the flag. Here AC is the flag. So here AC is height of the flag. Let H be the height of the flag, right? Here AC is the flag and AB is flag post. Flag post, right? Here we need to find H, AC, right? Height of the flag, right? So here we are taking angles of elevation and their respective opposite sides. And here adjacent side is given 20-meter. Distance between P and B is given. Therefore, the trigonometric function which relates opposite side and adjacent side is tan function. We are using tan function here, right? So therefore, so we'll consider tan 60 first. Tan of 60°. The formula says opposite side by adjacent side. Opposite side is BC. Opposite side of 60° angle is BC. Adjacent side is PB. PB, right? So for our convenience, we'll consider BA as Y, AC as X. Since it is height of the flag, we'll consider AC as X, AB as Y, right? So BC becomes, the whole distance BC becomes X plus Y, right? Divided by PB is 20 meter. So flag post is kept at 20-meter distance from some point P, right? Therefore, it is PB is 20 meter. Since tan 60 is root 3, we'll equate root 3 to the right hand side part. Therefore, X plus Y becomes 20 into root 3. Consider this as equation 1. We are going to find the value of X, which is nothing but height of the flag, right? So let us consider tan of 45°. Tan 45°, again by the formula opposite side by adjacent side. Here, so for 45° angle, opposite side is AB, adjacent side is PB. Since tan 45 is 1, so and AB is Y, the distance Y, divided by PB is 20. Therefore, Y is equal to 20 meter. Substitute the value of Y in equation 1, right? Equation 1 becomes X plus Y is 20 is equal to 20 into root 3. Therefore, value of X is 20 into root 3 minus 1, right? So, what is X? Height of the flag. 20 into root 3 minus 1 is height of the flag. So, look at the options. Option A is the right answer, right? So, as in the previous examples, here also we are using tan function, right? So, to find the height of the flag. Here, AB is the flag post, which is Y, and AC is height of the flag, right? And angles of elevations are given 60 and 45° respectively. So we are using tan functions to get the value of height of the flag like this. So option A is the right answer. Question number 9. The length of a slider between the top and a point on the ground is 56 meter in park. If the slider makes an angle alpha with the ground level such that, here is a slight correction students, it is not alpha, should be sine alpha is equal to 1 by 7, right? Such that sine alpha is equal to 1 by 7. Find the height of the slider. So let us consider a slider. Length of the slider between the top and a point on the ground. Let P be the point on the top right? Point. So, and on the ground, let us consider a point Q. So, length of the slider is 56 meter. If the slider makes an angle alpha, right, with the ground level. So, here ground level is QR. So, slider makes an angle alpha with the ground level such that sine alpha is equal to 1 by 7. We need to find height of the slider. So, here PR is height of the slider. Right? So sine alpha is given, right? So it's very easy question. Sine alpha is given 1 by 7. We know that sine of an angle is opposite side by hypotenuse, right? So opposite side to angle alpha, right? Opposite side by hypotenuse is equal to 1 by 7, right? So opposite side is height of the slider. Its height, and the hypotenuse is nothing but length of the slider, which is 56 meter, is equal to 1 by 7, right? Therefore, we need height of the slider is equal to, so 56 by 7, which is equal to 8 meter, right? Therefore, height of the slider is 8 meter. Option A is the right answer. Question number 10. A tower is 60 meter. An observer from the top of the tower makes an angle of depression 30 degree at the base of the building and angle of depression of 60 degree at the top of the building. What is the height of the building? So here let us consider a tower of height 60 meter. So let AB be the tower, right, of height 60 meter. An observer from top of the tower. So observer from top of the tower means at A makes an angle of depression 30 degree at the base of the building. And so this should be reverse, right? So angle of depression 30 degree at the top of the building here, right? So instead of base, it should be top of the building. An angle of depression here. So at the base of the building, depression of 60 degree at the base of the building. So for that, let us consider a building PQ, right? So we'll consider building PQ, right? So at the top of the building, so means at P, angle of depression is 30 degree, right? So join P and A, right? So we'll join a horizontal line PM to the tower, right? Since PM is parallel to QB and PM is equal to QB, right? So here, so angle made at P is 30 degree, which is angle of depression at the top of the building. Here PQ is building, PQ is building, and AB is the tower. AB is the tower, right? So angle of depression at the bottom of the building, right, is 60 degree. So now join Q and A. Q and A. So angle of depression at Q, so at the bottom of the building, is 60 degree. So here we need to find height of the building. So which is Q, PQ, not Q. So means height of the building. Let H be the height of the building, right? So because of the construction here, PQ is equal to MB. Here MB is also height of the building, right? And the whole value AB is 60 meter, right? So here, so angles of depressions are given, right? And the opposite sides are given. That means we need to find the opposite side. So which is MB, right? To find height of the building, we need MB and the whole value AB also, right? Therefore, again, we are using the trigonometric function which relates opposite side and the adjacent side here. So let us assume adjacent side QB as D. So distance between the building and the tower, Q and B is D, right? Therefore, PM is also D, right? So we'll write PQ is equal to MB is equal to H and QB is equal to PM is equal to D. These two are our assumptions, right? So here we need height of the building H. For that, let us consider tan 30 first. Tan of 30 formula says opposite side by adjacent side. Opposite side is AM, right, with respect to angle 30. So Opposite side is AM, adjacent side is PM. What is AM? So 60 meter minus height of the building gives AM, right? So this whole AB minus MB gives AM, right? Therefore, tan 30, so it is 1 by root 3 is equal to AM is 60 minus H by PM. PM is nothing but D. Therefore, let us consider D in the left hand side part. So 60 minus H into root 3 gives D. Consider this as equation 1. Now consider second angle of depression, which is 60 degree. So for that, we use tan functions. Tan 60 is equal to opposite side by adjacent side AB by QB, right? AB by QB. Since tan 60 is root of 3, AB distance is 60 meter, which is already given. So tower is 60 meter. Height of the tower is 60 meter. Therefore, AB is 60 meter by QB is D. Therefore, D is 60 by root 3. Right? Consider this as equation 2. So substitute the value of D, right, in equation 1. Therefore, equation 1 becomes, no, we are not substituting, sorry. We are just equating 1 and 2, right? So 1 is equal to 2. Therefore, we are equating the right hand sides. 60 minus H into root 3 is equal to 60 by root 3. Right? Therefore, 60 minus H is equal to 60 by root 3 into root 3. Right? Root 3 into root 3 is 3 itself. So 60 minus H is 60 by 3, which is 20. 60 minus H is equal to 20. Therefore, H is equal to 60 minus 20, which is 40. What is H? What is H? H is nothing but height of the building, right? So this PQ is height of the building is 40 meters. So look at the options. Option A is the right answer. Students, to solve this question, first we need to consider the tower, right, whose height is 60 meter, and a building, right? So which is whose height is H meters, right? And the distance between building and the tower be D meters, right? Which is QB. Now angles of depressions, right? So angles of depressions are given 30 degree and 60 degree respectively, right? So at the top of the building and bottom of the building respectively, right? So we use tan function. So using that, we are going to express the distance between tower and the building, D, right? So we are equating here right hand sides, since equation 1 is equal to equation 2, right? So height of the building is 40 meters, right? Option A is the right answer. Students, if you want to practice such type of questions on heights and distances, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 11. The angle between the legs of a compass is 60 degree and each leg is 10 centimeter long. How far apart the points on which the legs of the compass rest? So let us consider legs of a compass and the angle between the legs, right? So consider a compass, a geometrical instrument, right? Angle between the legs of a compass is 60 degree and each leg is 10 centimeter long. So each leg of a compass is 10 centimeter long. So 10 centimeter. So for our convenience, we'll consider AB and AC. Right? AB and AC are the legs of a compass. Here the question is, how far apart the points on which the legs of the compass rest? How far apart the legs of the compass rest means we need to find the distance BC. Now join B and C, right? Join B and C. So we have got a triangle here in which angle A is 60 degree and two sides are equal. Here two sides are nothing but, so two legs of a compass, right? Two sides are equal. In a triangle, if two sides are equal, their opposite angles are also equal, right? Therefore, so we can say angle B is equal to angle C, right? So since AB is equal to AC, so angle B is equal to angle C. Their opposite angles are equal, right? So in a triangle. Therefore, so what is the measure of angle B and angle C? Right? So to know the value of BC, we should know the angles, right? Depending upon the measure of these two angles, we can decide what type of triangle it is, ABC, right? Later we can find BC, right? So here angle B is equal to angle C. So what is the measure of angle B and C? So each equals to 60 degree, because angle A plus B plus C is equal to 180 degree, sum of the angles of a triangle, right? Since B is equal to C and angle A is 60 degree, so we can write B plus C as 2 times angle B or 2 times angle C, right? 2 times angle B is 180 minus 60, which is 120. So angle B is equal to 120 by 2, which is 60 degree, which is also equal to angle C. So angle B is 60 degree, angle C is also 60 degree. Therefore, equiangular triangle. An equiangular triangle is also an equilateral triangle. Or in other words, in an equilateral triangle, all the angles are equal. So each angle is equal to 60 degree, right? Therefore, so an equiangular triangle is also an equilateral triangle and vice versa, right? An equilateral triangle is also an equiangular triangle. Equilateral means all the sides are equal. Therefore, BC is also 10 centimeter, right? How far apart the points on which the legs of the compass rest? So legs of the compass, so these two legs rest at 10 centimeter apart, right? 10 centimeter apart. Therefore, option B is the right answer here. So these type of questions are very easy, students. Just we have to understand the concept here, right? Since two legs of a compass are apart, right, at some distance, and the angle between them is already given, and length of each leg is given, so 10 centimeter and 10 centimeter, right? So the distance between B and C depends on angle made at B and C, right? Since two sides in a triangle are equal, their opposite angles are equal. Therefore, angle B is equal to angle C, which is equal to, each angle is equal to 60 degree. Therefore, we have an equiangular triangle, which is also an equilateral triangle. Lateral means the sides, equal sides, right? Therefore, BC is also 10 centimeter. Therefore, option B is the right answer. Question number 12. An aeroplane, when flying at a height of 5,000 meters from the ground, passes vertically above another aeroplane at an instant. When the angles of elevation of the two aeroplanes from the same point on the ground are 60 degree and 45 degree respectively, the vertical distance between the aeroplanes at that instant is. So let us consider an aeroplane flying at a height of 5,000 meters from the ground, right? So if this is the ground level, so from the ground, an aeroplane is flying, right? So at a height of 5,000 meter. So we'll consider this as point P. So point P to first aeroplane distance is 5,000 meter, right? So the height at which first aeroplane is flying, right? And it passes vertically above another aeroplane. So we'll consider another aeroplane A2, right? So when the angles of elevation of the two aeroplanes from the same point on the ground. So let us consider any point on the ground. So say for example, Q. Let Q be the point on the ground. So from that point, right? So the angles of elevations made by two aeroplanes are, so these two angles are 60 degree and 45 degree respectively, right? Here angle A1QP is 60 degree, whereas A2QP is 45 degree. These two are angles of elevations made by two aeroplanes at any point, at the same point, single point on the ground. Here we need to find vertical distance between the aeroplanes. That means A1, A2 distance we need to find, right? So let h be the distance between, or x, any letter you can consider. Let h be the distance between two aeroplanes, and the total distance from A1 to first aeroplane to P is 5,000 meter. right? Here the angles of elevations are given. So we need to find vertical distance. So that means opposite side, a portion of opposite side we need to find, right? So for that, let us consider distance between a point on the ground and this point P, Q to P distance be D, right? Therefore, we are going to use the trigonometric function which relates opposite side and the adjacent side, right? Considering angle P is 90 degree, right? Because of that, we have got two right angle triangles. So A1QP and A2QP. So apply the trigonometric function. So here tan 60. Tan 60 is formula, according to formula, opposite by adjacent side. Opposite side to 60 degree is A1P. Its adjacent side is QP, right? So what is A1P? The total distance, which is, so 5000 meter divided by QP is, according to our assumption, D is the distance, right? From Q to P, whereas tan 60 is root 3. Therefore, we can consider D as 5000 divided by root 3, right? So now consider tan 45 degree. Tan 45 degree is again opposite by adjacent. So here opposite side of 45 degree angle is A to P, whereas its adjacent side is QP. So what is A to P? So A to P is total distance 5000 minus, so vertical distance between two planes, which is H, right? So we'll consider A to P as 5000 minus H by D, where tan 45 is 1. Therefore, D is equal to 5000 minus H. So considering the first equation as 1, second equation 2, right? So equation 1 is equal to equation 2, right? So both the equations give the value of D. Therefore, so we'll equate the right hand sides. 5000 by root 3 is equal to 5000 minus H, right? According to the question, we are going to find the vertical distance between two aeroplanes, which is H, right? Therefore, find the value of H. So here, H is equal to 5000 minus 5000 by root 3. We'll take out 5000 as common number. So 1 minus 1 by root 3, or in other words, H is equal to 5000 into, so taking root 3 as LCM. So in the numerator, we'll have root 3 minus 1, right? So the vertical distance between two aeroplanes is 5000 into root 3 minus 1 by root 3. So look at the options here, given here, 5000 into root 3 or option C, both are same. 5000 into root 3 minus 1 by root 3 or 1 minus 1 by root 3, both are same, right? So option C is the right answer. Question number 13. At a point on a level plane, a tower subtends an angle theta and a flag staff a feet in length at the top of a tower subtends an angle pi. The height of the tower is. So very easy question, students. Here let us consider a tower. Let AB be the tower, right? At a point on a level plane. So we'll consider a level plane BP. BP with the level plane, right? At a point on the level plane. So a tower subtends an angle theta. So the tower AB, we'll mention it as tower AB, subtends an angle theta. So angle at P is theta here. At a point on the level plane, it subtends an angle theta. And a flag staff A feet in length at the top of the tower. Here flag staff is at the top of the tower. So we'll consider a flag staff, right, of length A feet. A feet, right? It subtends an angle theta at the same point, right, on the level plane. Therefore, so let AC be the flag staff of length A. It subtends an angle pi, right? So at the same point on the level plane, so this angle is pi, right? The height of the tower is, so we need to find height of the tower AB. So let H be the height of the tower, right? So here H is height of the tower, height of the tower. how this height of the tower and height of the flagstaff and the angles pi and theta are related, right? For that, since height of the tower is opposite side of angle theta, right? And a flagstaff height is a portion of opposite side of theta plus phi, a portion of opposite side, right? Therefore, we are using tan function, right? So as in the previous examples, here also tan theta is equal to, so opposite by adjacent. So here adjacent side is distance between point on the plane and the tower, right? So let d be the distance. Since it is constant, so we'll name it as d or pb itself. So there will not be any change. So we'll consider it as pb or d, right? Tan theta is height of the tower, opposite by adjacent side is pb. So here we need pb since it is constant. So h by tan theta. pb is h by tan theta. Consider this as equation 1. Now let us consider tan of pi plus theta, pi plus theta. So this whole angle P is pi plus theta is equal to, again my opposite side by adjacent side. Here opposite side is BC, the whole height. Adjacent side is PB. So what is BC? BC is, so length of the flagstaff or height of the flagstaff plus height of the tower. Therefore, A plus H divided by PB. Therefore, PB is equal to, in this case also PB is equal to A plus H divided by tan of pi plus theta or theta plus pi. So consider this as equation 1, equation 2. So we can equate equation 1 and 2, right? So 1 is equal to 2. So equate the right hand sides. So H divided by tan theta is equal to A plus H divided by tan theta plus pi, right? Since in the given options, so all these options are in terms of cos and sine, right? So let us express tan in terms of cos and sine. So we know that tan theta is equal to sine theta by cos theta, right? Sine theta by cos theta. So left hand side becomes h divided by tan theta is sine theta by cos theta is equal to A plus H divided by tan theta plus pi is sine theta plus pi divided by cos theta plus pi. Theta plus pi. Take this cos theta, denominator of the denominator to the numerator. Numerator becomes H into cos theta by sine theta is equal to A plus H into cos theta plus pi. Right? So this cos theta goes to numerator divided by sine theta plus pi. Right? So here we need height of the tower is asked. We need the value of H, right? Height of the tower. So let us club the terms which contain H, right? So by cross multiplication, H into cos theta into sine theta plus pi is equal to A plus H into sine theta into cos of theta plus pi. Right? Now we can easily club all H terms, right? So just expand this RHS part. So H into cos theta into sine theta plus pi is equal to, so here A into sine theta into cos theta plus pi, A into sine theta into cos theta plus pi plus next term is H. H into sine theta into cos theta plus pi. Right? Now we can easily club all H terms. So there are two terms which contain H. Right? So LHS part minus the term in the RHS part which contains H. So H, by taking H as common, so the remaining terms are cos of theta into sine theta plus pi minus, this term becomes minus, into sine theta into cos of theta plus pi is equal to a sine theta into cos of theta plus pi, right? Here the LHS part, in the LHS part, except H, the remaining term is in the form of sine A cos B minus cos A sine B, right? So sine A cos B minus cos A sine B is nothing but sine of A minus B. Sine of A minus B. Here, sine A is, so A is theta plus pi, B is theta, right? Sine A cos B minus cos A. A is theta plus pi, B is theta, cos A sine B, right? Therefore, H into, so sine of A minus B, A is theta plus pi minus B is theta. Sine of A minus B is equal to A sine theta cos theta plus pi. Therefore, H into sine theta plus pi minus theta. Theta and theta will get cancelled here, right? So, we have sine pi into H in the LHS part. So, we need only H. H is equal to A sine theta into cos of theta plus pi whole divided by, so this sine pi becomes, yes, so sine pi will go to the denominator. So value of H, height of the tower, is A sine theta cos theta plus pi divided by sine pi, right? Height of the tower, A sine theta. So look at option B, A sine theta into cos theta plus pi divided by sine pi, right? Option B is the right answer. Question number 14. The angle of elevation of the top of a TV tower from the 3 points A, B, and C in a straight line in the horizontal plane through the foot of the tower are alpha, 2 alpha, and 3 alpha respectively. If AB is equal to A, then the height of the tower is. So let us consider a tower, right? So let PQ be the tower, right? So angle of elevation of the top of a TV tower from 3 points in a straight line in the horizontal plane. So we'll consider 3 points A, B, and C. So these three are the angles, and angle of elevation at these 3 points A, B, C are alpha, 2 alpha, and 3 alpha respectively. Right here, AQ is the horizontal plane. AQ is the horizontal plane and AB value is given. So distance AB is given, which is A, small a. So we need to find height of the tower, PQ, right? So for that, let us consider even the angle of depression also. Right? For our better understanding, we'll consider angle of depression. We all know that angle of elevation of the top of any tower or anything it may be is equal to angle of depression. Angle of depression. These two angles are made with the horizontal, right? Here angle of depression is, so with respect to point A, right, is alpha, right? So and this alpha made at P is equal to angle of depression. Angle of depression. So this angle is with the horizontal line which is passing through, or imaginary horizontal line which is passing through point P, right? Which is horizontal to the ground surface, right? So angle of depression is also made with the horizontal line, even the angle of elevation. Therefore, these two angles are equal, right? These two are alpha. So when it comes to angle of elevation 2 alpha, right, made at B, which is equal to angle made at P, this whole angle, which I am showing now. Therefore, the small angle, which I am mentioning APB, is also alpha. So that alpha plus alpha is equal to 2 alpha. This gives the whole angle, right? If you consider PM as the horizontal, or yes, horizontal surface, right, or imaginary horizontal line, angle MPB, right, I'll mention angle MPB is equal to 2 alpha. because of the concept of angle of elevation is equal to angle of depression, right? But already MPA is alpha, right? Which is sum of angle MPA plus angle APB, right? Since angle MPA is alpha, APB is also alpha, right? So here consider triangle APB. In triangle APB, right? So angle made at A, which is angle of elevation, PAB, angle made at A is alpha, which is equal to angle APB. Two angles are equal, right? Opposite angles are equal. Therefore, their opposite sides are equal, right? So the angles opposite to equal sides are equal and vice versa, right? Sides opposite to equal angles are also equal, right? Therefore, so BP is equal to A, this side, right? Therefore, AB is equal to BP or PB is equal to A, right? Now consider 2 alpha, angle of elevation 2 alpha and its sine function, right? Since we are going to find height of the tower, right? And this, one of the sides is known here, which is PB, right? So here PB is adjacent side to 2 alpha angle, right? So using the concept of opposite side by hypotenuse, which is sine alpha or sine theta, right? Sine theta. So we can easily find height of the TV tower, right? Therefore, in triangle PBQ, consider the triangle PBQ, sine 2 alpha, right? Sine function relates opposite side and hypotenuse. Therefore, it is sine 2 alpha is again opposite by hypotenuse. Here, opposite side is height of the TV tower divided by hypotenuse is A, right? Hypotenuse is A. Therefore, height of the tower is equal to A into sine 2 alpha, right? So the answer is A sine 2 alpha. So option C is the right answer. Students, first we need to find side PB, which is equal to A. Using the concept, angle of elevation is equal to angle of depression, right? So the alternate angles are equal using this concept. So angle PAB is equal to APB, right? Though these angles are alpha, right? Then their opposite sides are equal. Therefore, PB is equal to A. Now consider triangle PBQ. In that, use sine function sine 2 alpha, which relates opposite side and hypotenuse. Here, opposite side is height of the tower. Therefore, we can easily find height of the tower, which is equal to A sine 2 alpha. Hence, option C is the right answer. Question number 15. Distance between the two buildings is 140 meters. From the top of the first building, the angle of elevation when seen from the top of the second building is 60 degree. Find the height of first building if the height of the second building is 45 meter. Students, let us consider two buildings, right? So let the two buildings be AB and CD. AB and CD, right? So distance between two buildings is given, which is 140 meters, right? So B and D distance is 140 meters. From the top of the first building, from point A, right? The angle of elevation when seen from the top of the second building. So when seen from the top of the second building, angle of elevation, right? So when seen from the second building, so angle of elevation is 60 degree. That means angle made at C is 60 degree. So let us join C and a point on the first building, which let it be E. Right? Here CE is equal to BD. CE is equal to BD, which is 140 meter, and CE is parallel to BD also. And here what is asked? Find the height of the first building. If the height of the second building is 45 meter. Here CD, height of the second building is 45 meter. We need to find AB, right? Since CD is equal to BE, according to our construction CE, right? So CD is equal to BE, which is 45 meter. We need to find height of the first building. Therefore, what is AB, right? So AB is AE plus EB. We need to find this, right? For that, let us consider angle of elevation 60 degree, right? So in which we know the value of CE in triangle AEC, we know the value of CE, which is 140 meter. So CE is adjacent side to angle 60 degree, right? And AE is opposite side. So we'll consider AE as, for example, H, right? H. So unknown, the AE value is unknown for us, right? So we'll consider it as H. So the trigonometric function which relates the opposite side of the angle and adjacent side of the angle is tan function. First, let us use tan 60, right? So using tan 60 function, so which is AE by EC. What is tan 60? So value is root 3 is equal to AE, according to our assumption, it is H by 140, right? Here, H value, right? A to E distance is 140 into root 3. Here we need whole AB value, right? Which is AE plus EB, right? Therefore, AB, height of the first building is, what is AE? Which is nothing but H, right? So AE plus EB, A is nothing but 140 into root 3 plus what is EB? So EB is equal to 45 meter, right? So BE or EB is 45. Right? Therefore, height of the first building is 140 into root 3 plus 45 meters. Right? 140 into root 3 plus 45 meters. Option A is the right answer. Question number 16. An observer measures angles of elevation of two towers of equal heights from a point between the towers. If the angles of elevation are 60 degree and 30 degree and the distance of nearer tower is 100 meters, then the height of each tower and the distance between the towers respectively are. Here students, so an observer measures angles of elevation, right, from a particular point between the towers where so two towers having equal heights. So we'll consider two towers having equal heights. Let H be the height of each tower, right? So let AB and CD be the two towers. So an observer, so between these two towers, so an observer observes the two towers such that angles of elevations are 60 degree and 30 degree respectively. So here tower CD is nearer to the observer. Therefore, angle of elevation is greater, right? So angle of elevation is greater for nearer tower, so which is 60 degree, and the lesser angle of elevation is 30 degree. This is for the tower AB, right, which is not nearer to the observer here. So AOB is 30 degree. So we need to find height of each tower and distance between two towers. So that means, so the whole distance BD we need to find out. So what is BD? And height of each tower. So AB and CD. So AB is equal to CD is equal to H. What is height of each tower? For that, again, we are using tan functions. So here it is given that, so nearer tower is 100 meter from the observer. Therefore, OD distance is 100 meters. Right? So we'll consider tan 60 degree is equal to, so opposite side is CD, which is nothing but height of the tower, by adjacent side, which is OD. So since tan 60 is root 3, CD is height of the tower by 100 meter is the adjacent side. Therefore, height of the tower is equal to root 3 into 100 meters. We need to find height of each tower, right? So which is nothing but AB, which is equal to CD, and the distance between the towers. Therefore, look at the options. 100 into root 3, either C or D is the right answer. No need to go for A and B options. Either option C or D is the right answer. So let us consider distance between two towers. For that, we'll consider tan 30 degree. right? Why we are taking tan 30? Because we need the distance BO also. To find the whole distance BD, we need BO, and OD is already given, right? So to find BO, so we need tan 30, right? So opposite side is height, right? Height of the tower divided by BO. Let BO be the distance D or X, anything you can consider, right? Tan 30 is 1 by root 3, so is equal to H by BO, right? Therefore, H is equal to, what is the value of H? Root 3 into 100. Just now we had calculated. Therefore, we can directly take BO is equal to, so H is root 3 into 100, right? So into root 3. It is not divided by this root 3. When it goes to a right hand side, it becomes into root 3, right? Therefore, 3 into 100 gives 300, right? So is the distance of another tower, right? Distance of another tower from the observer, which is 300 meters, BO. Therefore, BD, distance between two towers is BD, is equal to BO plus OD. BO just now we have calculated as 300 meters, plus OD value is already given, so, right? So the nearer tower distance from the observer is 100 meters. Therefore, distance between two towers is 400 meters, right? And and so what is the question asked at first? Height of each tower is 100 into root 3 meters, right? Therefore, the answer is option D, right? Height of each tower is 100 into root 3 meter, and distance between two towers is 400 meters, right? Option D is the right answer. I'll repeat once again, students. So first we need to consider two towers of equal heights, and between the two towers there is an observer, right? From the point of the observer, there are two angles of elevations with respect to two towers. So for the tower which is nearer to the observer, angle of elevation is greater, right? So compared to the other tower. Therefore, so angle made at COD is 60 degree, whereas AOB is 30 degree, right? First, we need to find height of each tower. For that, we'll consider tan 60. So height of the tower divided by adjacent side, which is 100 meter. Therefore, height of the tower is equal to root 3 into 100 meters. Right? First answer we got. For the second answer, we need BO distance. So distance of the another tower, second tower, right? From the observer. For that, we'll take tan 30. So opposite by adjacent side. So using that, BO is equal to 300 meters, right? Therefore, we need the total distance between two towers, BD, is 300 plus 100, which is 400 meters. Hence, option D is the right answer. Question number 17. On the ground level, the angle of elevation of top of a tower is 30 degree. On moving 20 meter nearer the tower, the angle of elevation found to be 60 degree. The height of the tower is. So let us consider a tower AB, right? Or you can consider it as PQMN, right? So let AB be the tower. On the ground level, angle of elevation of the top of the tower is 30 degree. So let us consider any point on the ground level such that angle of elevation of the top of the tower. Here top of the tower is at A, right? So from point A, here angle of elevation is found to be 30 degree, right? On moving 20 meter nearer the tower. So nearer the tower on moving. So here, so we'll consider a point Q, right, on the ground level. So on moving 20 meter nearer the tower means PQ distance is 20 meter. The angle of elevation found to be 60 degree. So at point Q, angle of elevation found to be 60 degree. So here we need to find height of the tower, which is AB, right? Let H be the height of the tower. Here we have PQ distance, right? So here we have two angles of elevation. So as in the previous cases, here also we are using tangent function, tan function. For that, we need adjacent side also. Here, so for 60 degree angle, adjacent side is QB. So let us consider Q as the adjacent side to angle 60 degree, right? So therefore, here height of the tower. So here H is height of the tower, right? Height of the tower. So we'll consider tan 30 first, right? So in both the cases, we need height of the tower, right? Because height of the tower is nothing but opposite side to each angle, right? So tan 30 is equal to opposite side by adjacent side. So here opposite side is AB, adjacent side to angle 30 is PB. Since tan 30 is 1 by root 3 is equal to AB is height of the tower divided by PB is PQ by QB, right? So we'll write it as 20 plus X, right? Now we'll take the value of height. Height of the tower is equal to 20 plus X divided by root 3. Consider this as equation 1, right? Now let us consider tan 60 degree. Tan 60, again opposite side by adjacent side. So H by X, right? H by X. Since tan 60 is root 3, which is equal to H by X. Again, we'll consider H is equal to root 3 into X. Consider this as equation 2. From 1 and 2, you can equate 1 and 2, right? Therefore, otherwise, since we are going to find height of the tower, directly you can consider X as H by root 3, right? So in both the ways it is possible, right? We'll go for H, right? So that we can equate equation 1 and 2. So right hand sides are equal. 20 plus X by root 3 is equal to root 3 into X. So 20 plus X is equal to root 3 into root 3X is 3X. Therefore, 2X is equal to 20. Value of X is equal to 10. So this value distance between Q and B is how much? 10 meter. We need H, right? So substitute the value of X in either equation 1 or 2, right? So equation 2 becomes, so height is equal to root 3 into 10 meters. 10 root 3 meters is the height of the tower. So option B is the right answer, 10 root 3. Otherwise, another method is here. So once we get tan 60 as H by X, so we'll take the value of X. X is equal to H by root 3. Substitute the value of X in equation 1, right? So H becomes 20 plus, what is X? X is H by root 3 whole divided by root 3, right? So in the numerator, we have root 3 as the LCM of the denominator, right? So 20 root 3 plus H whole divided by root 3 means into root 3, right? Denominator into denominator. Therefore, H is equal to 20 root 3 plus H. Is it H only? So 20 plus X is equal to H by root 3. Yes. By 3. Therefore, we have 3H minus H is equal to 20 root 3. Right? 2H is equal to 20 root 3. Therefore, value of H is equal to 20 by 2, which is 10 root 3 meters, is the height of the tower. Right? Either you can substitute the value of X in equation 1, or you can equate equation 1 and 2, right? So that both the left hand sides are equal, so that you can equate right hand sides to get the value of X. Then substituting the value of X in either in equation 1 or 2, so you will get the value of H, which is height of the tower. Therefore, option B is the right answer. Question number 18. The angle of elevation from the bank of a river of the top of a tree standing on the opposite bank is 60 degree. The angle of elevation becomes 30 degree when observed from a point 40 meters backwards in a direction perpendicular to the length of the river. What is the width of the river, right? So let us consider a tree on the other side of the river, right? So on the opposite bank. Therefore, so we'll consider AB as the tree. Let H be the height of the tree, right? Here H is height of the tree. Height of the tree. So here angle of elevation from bank of a river, from other side of the river, right? Angle of elevation from a particular point, let it be C, right? Is observed to be 60 degree, right? So angle made at C is 60 degree. These two are banks of the river, right? So angle of elevation becomes 30 degree when observed from a point 40 meter backwards. So if we move 40 meter backwards from the first bank of the river, right? Let the point be D here. So CD distance is 40 meters. So in a direction perpendicular to length of the river. So if you consider this direction, so this is length of the river. Here CD is perpendicular to length of the river, right? So angle of elevation becomes 30 degree, right? So when you move backwards from the bank of the river, so the angle of elevation becomes 30 degree. So here we need to find width of the river. Width means CB will be the width of the river, right? So width of the river, since river is flowing in this direction or in opposite direction. So this becomes a CD. This becomes width of the river, right? For that, again, we are taking tan function, right? So based on height of the tree, we can equate height of the tree in both the cases for tan 30 and tan 60, right? Therefore, we can easily find width of the river. So let width of the river be X meters, right? So here we'll take X as width of the river. Width of the river. So we'll consider tan 30 degree first. Tan 30 is opposite side by adjacent side. So adjacent side to 30 degree angle is, so CD plus CB. So which is 40 plus X. Since tan 30 is 1 by root 3 is equal to H by 40 plus X. Therefore value of H is 40 plus X by root 3. Consider this as equation 1. Let us consider tan 60. Right? So tan 60, again opposite side by adjacent side. Opposite side is height of the tree. By adjacent side to 60 degrees, width of the river, which is nothing but X. Right? Since tan 60 is root 3 is equal to H by X, or H is equal to root 3 into X. So consider this as equation 2. Therefore, so we can equate 1 and 2. Right? So equate the right hand side. So root 3 into X is equal to 40 plus X by root 3. So root 3 into root 3 becomes 3 into X. Take this H to LHS part, it becomes minus X is equal to 40. So 2X is equal to 40. So value of X is 20. What is X? Width of the river. 20 meters is the width of the river. Alright. So option B is the right answer. So students, here we are taking a tree, right, on the other side of the river. So let AB be the tree, or whose height is H meters, right? So when the tree is observed from other side of the river, on the other bank of the river, so angle of elevation is, that means observed to be 60 degree. So when we move backwards, right, when we move backwards, so from a point D, say for example, right, which is at 40 meters from the bank of the river, so angle of elevation is observed to be 30 degree, right? Here we need to find width of the river. For that, so we are using tan functions. Consider tan 30 and tan 60. Solve for height. So height of the tree. Equate two equations, right? So particularly the right hand side of the two equations. to get the value of x. So you get x as 20 meters, right? So option B is the right answer. Question number 19. The angle of elevation and angle of depression both are measured with. Options are the vertical direction only, the horizontal direction only, both horizontal and vertical directions, and none of this. Right? None of the above. So here, students, if a person stands and looks up at an object. So for example, a person is standing here, an object is here. So it may be a cliff or the tower, say for example. Right? So if a person stands and looks up at an object, the angle of elevation. So here he is looking up at an object which is top of the tower. Right? So angle of elevation is the angle between the horizontal line of sight. Horizontal line of sight means this direction. His horizontal line of sight, right, and the object. Here object is top of the tower, so angle between the horizontal line of sight, so I'll mention it, horizontal line of sight, and the object, right, is called angle of elevation. Angle of elevation, right? So if the same person stands and looks down at an object, so we'll consider another case. A person is standing here at the top of the tower and he is observing something here. So it may be a small tower or small cliff, right? So if a person stands and looks down at an object, looks down, he is looking down at an object. So the angle of depression is the angle between the horizontal line of sight. His horizontal line of sight is this one, right? And the object is here. Therefore, angle between his horizontal line of sight is this one, line of sight, and the object is here, top of the cliff or top of the tower, anything it may be, right? So angle is, this is called angle of depression. So if you consider a horizontal line from the top of the object, right? So to the, it may be a cliff or a rock, whatever, a tower, right? So if you draw a horizontal line, so since two lines are parallel lines, you can equate angle of depression to this angle. So which is again angle of depression, alternate angles, right? Therefore, angle of depression and angle of elevation both are measured with the horizontal direction only, right? Horizontal direction only. Therefore, option B is the right answer. So the reason is, so by taking two examples, if a person stands and looks up at an object, here in the first case, case 1, looks up at an object, the angle of elevation is the angle between the horizontal line of sight, his horizontal line of sight, and the object. If the same person stands and looks down at an object, the angle of depression is angle between the line of sight, right? So horizontal line of sight and the object. So object is downwards here, right? Therefore, since these two angles are equal, angles of depression are equal because of the concept alternate angles. Alternate angles. So angles of elevation and depression both are measured with the horizontal direction only, right? So with the horizontal line of sight. Therefore, option B is the right answer. Question number 20. A radio transmitter antenna of height 100 meters stands at the top of a tall building. At a point on the ground, the angle of elevation of bottom of the antenna is 45 degree and at the top of the antenna is 60 degree. What is the height of the building is asked. So here student, let us consider a radio transmitter antenna at the top of a building, right? So for that we need to consider the building first. So let AB be the building. So at the top of the building, there is a radio transmitter antenna, right? So we'll consider antenna as AC, right? So height of the antenna is 100 meter. is given, right? So at a point on the ground, so means consider any point on the ground somewhere here. We'll consider P as the point on the ground. Angle of elevation of bottom of the antenna is 45 degrees. So here we'll consider the plane surface of the ground. So angle of elevation of bottom of the antenna, here bottom of the antenna is A, right? So AC is, we'll mention AC as antenna and AB as building, right? So here, so at the bottom of the antenna, angle of elevation from a point on the ground, right? So this is called angle of elevation is 45 degree. And so angle of elevation of the top of the antenna is 60 degrees. So here C is top of the antenna, right? So from C, draw a line, right, to join P. Here angle of elevation is 60 degree. So what is the height of the building? So height of the building is AB here, right? So we need to find AB, height of the building. Height of the building. So let us consider H as height of the building, right? Or X, right? Height of the building. Here, this height of the building H is opposite to the angle 45 degree, right? So let us consider D as distance between the point and the building, right? Point on the ground and the building. So considering the opposite side of the given angles of elevation and the distance between the point and the building, so we can use tan function, right? As in the previous question, here also we are using tan function. So we'll consider tan 45 degree. So tan is opposite side by adjacent side. Here opposite side of 45 degree is AB, which is height of the building. By adjacent side is PB. Adjacent side is PB, right? So AB is height of the building. PB, according to our assumption, it is D. Since tan 45 is 1, so we can say, so height of the building is nothing but distance between point on the ground and the building, right? So let us consider tan of 60 degree. Tan 60 degree is equal to, so opposite by adjacent side. Opposite side of 60 degree is BC, the whole BC divided by PB. Since tan 60 is root of 3 and BC is, so sum of height of the building and height of the antenna, right? So which is 100 plus H. BC is 100 plus H divided by PB is D, right? Since we are going to find height of the building, so let us consider value of D here, right? In place of D, we'll write H because already we have proved H is equal to D, right? So 100 plus H divided by H. Therefore, so root 3 into H minus H gives 100, or H into root 3 minus 1 is equal to 100. Therefore, height of the building is 100 by root 3 minus 1. Right? Look at the options. So in the four options, given four options, so there is no denominator part. So that means we need to convert the denominator as whole number here, right? For that, so multiply the given fraction 100 by root 3 minus 1, right? So by root 3 plus 1, right? Inverse of root 3 minus 1 is root 3 plus 1 and divide by root 3 plus 1, the same value. There will not be any change in the value of the given fraction, right? Therefore, 100 into root 3 plus 1 divided by, denominator is in the form of a plus b into a minus b, which is a square minus b square, right? Therefore, denominator can be written as root 3 the whole square minus 1 square. Therefore, 100 into root 3 plus 1 divided by root 3 the whole square is 3 minus 1. Therefore, we'll get 100 by 2 into root 3 plus 1 or 50 into root 3 plus 1, right? So, height of the building is 50 into root 3 plus 1. Look at the options. Option C is the right answer. 50 into root 3 plus 1. Here, students, we are using the simple concept that, so by taking H as height of the building and 100 meter is height of the antenna, which is already given. So let us assume D is the distance between point on the ground and the building, right? Angles of elevations are already given. Angles of elevations are already given. Using tan function, So we have got h is equal to, height of the building is equal to d, right? So now take tan of 60 degrees. So in that we have d in the denominator. So in place of d, we are writing h. Therefore, finally, we'll get the value of h as, so after simplification, so 50 into root 3 plus 1 meter is height of the building. So option C is the right answer. Question number 21. Two poles of equal heights stand on either side of a roadway which is 100-meter wide. At a point on the roadway between the pole, the angle of elevation of the tops of the poles are 60 degree and 45 degree. Find the height of the poles. Here students, two poles of equal heights, right? So we'll consider two poles of equal heights. So let the poles be AB and CD. Stand on either side of a roadway which is 100-meter wide. So distance between two poles is, so this distance between two poles is 100 meters, right? So at a point on the roadway between the pole, so between the pole, so we'll consider a point on the roadway. So let P be the point on the roadway. So the elevation of the tops of the poles are 60 degree and 45 degree, right? So tops of the poles are A and C, right? So elevation of the tops of the poles means, so from P to A, if we draw a line, right? So angle of elevation at P, right? So here it makes an angle which is called angle of elevation. Here, since P, the point P is nearer to the pole AB, or pole AB is nearer to the point on the roadway. So here angle of elevation is greater, right? Angle of elevation is greater for nearer pole, right? And which is lesser for the other pole, right? Which is how much? 45 degree. Find the height of the poles. Since two poles having same height, so we'll consider H and H are heights of the poles, right? So we have to find this height. For that, so here angles of elevations are given, right? And these heights are the opposite sides for respective angles, right? So here the total distance between two poles is given. So we'll consider x and y as, so distance of two poles from the point P, right? Using opposite side and the adjacent side. Opposite side is height of the pole and adjacent side to the angle of elevation is x and y respectively, right? For these two angles of elevation. So we are going for tan functions. So tan 45 degree is, so opposite by adjacent side. So which is CD by PD. CD by PD, right? So tan 45 is 1. CD is height of the pole CD, right? And PD is Y. Therefore, so height of the pole is nothing but Y, right? Consider tan 60 degree. So H by X. So height of the pole divided by adjacent side. Tan 60 is root 3 is equal to H by X. Therefore, we'll consider X. X is equal to H by root 3. So we have Y and X. So if we consider these two as equation 1 and 2, add these two equations so that you will get X plus Y. So what is X plus Y? X plus Y is nothing but distance between two poles, right? So we'll consider that first because we know the distance between two poles value. We don't know the individual value of X and Y, right? So equation 1 plus 2 gives, right? So if you consider y is equal to h as equation 1, so x plus y is equal to, right hand side of equation 1 is h plus right hand side of equation 2. Therefore, x plus y, what is x plus y? Total distance between two poles, 100 meter, is equal to h into 1 plus 1 by root 3, right? So 1 plus 1 by root 3. Therefore, h into, so take root 3 as LCM, numerator becomes root 3 plus 1. Therefore, height of each pole is equal to 100 into root 3 divided by root 3 plus 1. meters. Right? 100 into root 3 divided by root 3 plus 1. Let's look at the options. So option B, 100 into root 3 by 1 plus root 3. Right? Option B is the right answer. Question number 22. The angle of elevation of the top of two vertical towers as seen from the middle point of the line joining the foot of the towers are 60 degree and 30 degree respectively. The ratio of the heights of the towers is. So here let us consider two vertical towers first, right? So AB and CD with the two vertical towers. AB and CD. Right? So angle of elevation from the middle point of the line joining the foot of the towers. Here B and D are foot of the towers and middle point or midpoint of BD, right? Line joining these two foot of the towers is BD. BD is the line joining the foot and there is a midpoint. We'll consider it as P. From this midpoint, the angle of elevation of the top of two vertical towers. So angle of elevation of top of towers means A and C are the tops of two towers. So we'll consider angle of elevation from the midpoint P. Right? So are 60 degree and 30 degree respectively. So for taller building, maybe it is a tower. Yes, for taller tower, the angle of elevation is greater, right? Therefore, it is 60 degree. And angle of elevation is lesser for smaller tower, right? Which is 30 degree, right? Therefore, the ratio of heights of the towers. So here, students, let us consider H1 and H2 as heights of towers. We need to find H1 is to H2, right? So let us consider, so 2D for our convenience, we'll consider 2D as the distance between two towers, right? Since P is midpoint of BD line, so BP is equal to D, right? Half of 2D, half of total distance becomes D and PD also is D, right? So towers are equidistant from the point P. Right? Two towers are equidistant from the point P. Therefore, so BP is equal to PD is equal to D. Right? So now consider tan 60 degree. Before going to the ratio of the heights of the towers, we'll consider their individual heights. Then we can go for ratio, right? Tan 60 is opposite side by adjacent side. Therefore, it is H1 by D. Adjacent side is BP. Therefore, it is D. Therefore, height 1, H1 is equal to, so tan 60 into D. What is tan 60? Root 3 into D. Whereas tan 30 degree is equal to, so opposite side of 30 degrees H2 by D. What is tan 30? 1 by root 3 is equal to H2 by D. Therefore, H2 is equal to D by root 3. We need the ratio of H1 to H2, right? So for that, so we'll consider H1 by H2, right? So to get the ratio, we need to divide one term by another term, right? So root 3 into D is H1 divided by D by root 3. So here denominator of the denominator will go to numerator and D will get cancelled. Therefore, we have root 3. So this goes to numerator. Root 3 into root 3. Therefore, 3 by 1, which is nothing but 3 is to 1, right? So ratio of the heights of the towers is, so 3 is to 1. Right? That means first tower is 3 times taller than the second tower, right? Second tower. Therefore, option D is the right answer. Question number 23. The angles of elevation of the top of a tower h meter tall from two different points on the same horizontal line are x and y, where x is greater than y. That means angle of elevation x degree is greater than y degree. Right? So what is the distance between the points? Here, students, let us consider a tower of h meter tall. Right? So consider a tower, AB be the tower. whose height is h meters, right? From two different points on the same horizontal line. So let us, from the base of the tower, consider a horizontal line, right? And consider two different points on the same horizontal line. Let the points be P and Q, right? From these 2 points, angles of elevation of the top. So top of the tower is A. So angles of elevation are, so angle P, which is x degree, because so x is greater than y, right? So since the point P is nearer to the tower, so angle of elevation is greater, right? Which is x degree. Or from point P, so the tower is very nearer, right? Therefore, angle of elevation is greater, and angle of elevation is y degree at Q, right? Here we need to find distance between the points. So distance PQ need to be calculated. So what is PQ, right? For that, again, let us go for tan X and tan Y, right? Because from tan X, you will get BP or PB. From tan Y, we will get BQ, right? Here PQ is nothing but the whole distance BQ minus BP. BQ minus BP. So if you find the value of BQ and BP, you can easily find BQ, right? Therefore, to get BQ, let us consider tan Y. Tan Y degree is opposite side, which is AB, by adjacent side, which is BQ, right? So what is AB? AB is height of the tower by BQ. Therefore, BQ, so distance from the tower to the point Q, right, is equal to h by tan Y. So let us consider this as equation 1. Let us consider tan X, right? So h by BP, opposite by adjacent. Therefore, BP is equal to h by tan X, right? So consider this as equation 2. Here we need PQ, right? Therefore, PQ is equal to BQ minus BP. Distance between 2 points is equal to BQ minus BP. So what is BQ? From equation 1, BQ is h by tan Y. BP is h by tan X from equation 2. So consider the LCM. LCM is tan X into tan Y. And the numerator becomes h into tan X minus h into tan Y, right? So we'll take h common in the numerator. So tan X minus tan Y whole divided by tan X into tan Y, right? Tan X into tan Y. Therefore, distance between 2 points, so PQ is equal to h into tan X minus tan Y divided by tan X into tan Y. Option C is the right answer, right? Question 24. From the top of a h-meter high cliff, the angles of depression of the top and the bottom of a tower are observed to be 30° and 60° respectively. The height of the tower is. So so height of the cliff is given h-meter, right? So let us consider a cliff, right? So a cliff AB. So let us consider a cliff AB whose height is h meters, right? H meters. So here cliff is nothing but a mass of rock that rises very high. So which is almost vertical, right? Mass of rock is called mass of rock that rises very high and which is almost vertical is called a cliff, right? Here height of the cliff is h meters and angles of depression of the top and bottom of a tower are observed to be. So here we need to consider a tower, right? So let CD be the tower. So we'll consider tower CD. So angles of depression from the top of a cliff, right? So here top of the cliff is A, right? From the top of a cliff, angles of depression, right, of the top of the tower is 30 degree. So always angles of, it may be angles of depression or angle of elevation. So these angles are measured with the horizontal lines, right? Therefore, so we have to draw a horizontal line. So let it be CP to the cliff, right? Therefore, angle of depression observed from the top of the cliff is 30 degree, right? And angle of depression, right? Angle of depression of the bottom of the tower, right? But here D is bottom of the tower. So in order to avoid the confusion, I'll write tower and the cliff here, right? So angle of depression of the bottom of the tower is 60 degree, right? Because so when it comes to the ground level, so angle, it may be angle of elevation or depression for higher objects or higher masses like cliff or rock. So angle of elevation or depression will be higher, right? Here the distance AB is greater than AP, right? Therefore, so angle of depression is greater at the bottom, lesser at the top of the tower, right? Because of this vertical distance, right? If vertical distance is greater, so angle of elevation or depression will be greater, right? Therefore, 30 degree and 60 degree. So we need to find height of the tower. So, right. So let us consider X as height of the tower, because already the height of the cliff is given. So this whole height is given already as H, right? So let us consider X as height of the tower. So we'll mention height of the tower, right? So to get X, right? So we'll go for tan 30 degree and tan 60 degree. Using that, you can easily get the value of PB. Since CD is equal to PB, right? CD is equal to PB, which is equal to X, because already we have drawn a parallel line CP to DB. Therefore, PB is equal to X, right? If you get the value of PB, so which is nothing but height of the tower, right? Which is because it is equal to CD, right? So to get PB, so we have to take tan 30 and tan 60 degree, because PB is a part of opposite side of angle 60 degree, right? Therefore, tan 30 degree and 60 degree we'll consider. So tan 30 is AP by DB. AP by DB. Right here, DB is distance between tower and the cliff. So for our convenience, we'll take it as D. D as distance between tower and cliff. Right? What is AP? The whole height of the cliff minus X value. Right? So the whole height of the cliff, which is AB, minus X. Right? Because PB is X divided by what is DB? So according to our assumption, it is D, right? Therefore, here tan 30 is 1 by root 3 is equal to H minus X by D. Therefore, so we'll consider D is equal to root 3 into H minus X, right? So now tan 60. Right? So why we are equating this root 3 into H minus X to D only? Because in both the cases, in tan 30 and tan 60, so you will get D as common measure, right? So distance between tower and cliff. So when we equate D and D, so D and D are equal, so we can equate the other side, right hand sides, right? Therefore, tan 60 is again opposite. Opposite side is height of the cliff by adjacent side is D. Since tan 60 is root 3 is equal to H by D. Therefore, D is equal to H by root 3. Right? So, from tan 30, we have got D as root 3 into H minus X. From tan 60, we have got D as H by root 3. Therefore, we can equate 1 and 2. Right? So, equating right hand sides, root 3 into H minus X is equal to H by root 3. Right? Simplify it. Root 3 into root 3 becomes 3 into H minus X is equal to H. Right? So 3H minus this H becomes 2H is equal to 3 into X. Right? So it becomes 3 minus 3x is equal to 0. So 2h is equal to 3x. So here we need height of the tower, not cliff. Height of the tower is asked, therefore, which is x. Therefore, x is equal to 2 by 3 into h. Right? 2 by 3 into h meters is height of the tower. So option D is the right answer. I'll repeat once again, students. So let us consider a tower and the cliff. So let h be the height of the tower, which is already given, and x be the h be the height of the cliff, which is already given, and x be the height of the tower. Right? Angles of depressions are given. Right? So from the top of the cliff, angles of depressions are 30 degree and 60 degree of the, right, of the top and bottom of the tower respectively, because angles of depressions and in case of angle of elevation, so if higher the tower or the cliff, so if more the vertical distance, more will be the angle. Right? It may be angle of elevation or angle of depression. Therefore, so if here angle of depression is 30 degree. Yes, angle of depression is 30 degree for the lower vertical distance and 60 degree for higher vertical distance, this distance. So by taking tan 30 and tan 60, so you have to equate the distance between tower D to the cliff, right? So distance between tower to the cliff to the right hand side part, so that you can equate the right hand side parts, right? So root 3 into h minus x is equal to h by root 3. Here we need the value of x. After simplification, you will get the value of x as 2 by 3 into h. Right? So students, if you want to practice such type of questions on heights and distances, right, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you all the best for your future exams.